Okay, guys, you have already been working on the test review for Tuesday. So I posted the answers and everything yesterday. So here's the video of me working everything out. And then on Monday, make sure you come into class with any questions that you might have so we can get you fully prepared for your test, which is on Tuesday. Remember, the stuff from Tuesday is everything from P2, P3, P4, P5, all the stuff we've been working on. So let's just make sure that we are getting prepared. So when I look at this first question, number 40, I'm going to distribute my exponents. Remember, we distribute to everything. So when we raise a power to a power, we multiply. So this gives me a to the negative 6 times power to a power, a to the 6th power, b to the 2nd, times b to the 12th, because of power to a power. Now we are multiplying same basis. If you notice here, we're going to add our exponents. So negative 6 plus 6 is going to give me 0. This is a to the 0 power. Then I have b to the 2 plus 12, which is 14. You guys, what's anything to the 0 power? It's just 1. So when this simplifies, it's just b to the 14th. If you wanted to move this negative exponent to the denominator and then subtract exponents, you would get the exact same answer if you would rather do that. Okay, again, we're going to distribute this negative 2 to absolutely everything. Absolutely everything. The numerator and the denominator. So I'm going to just rewrite everything. I have a to the negative 2nd, b to the negative 4th, c to the positive 6th. Power to a power, we multiply. Negative times a negative is a positive. So on the bottom, I have 2 to the negative 2nd power. I have a to the negative 4th power. And I have b to the 8th power. So in this case, I see all these negative exponents. I'm going to go ahead and move them so I can get everything to be a positive exponent, and then I can deal with things from there. So I'm going to move this down. This is going to move down. This is going to move up. And my a to the 4th is going to move up as well. My b to the 8th and c to the 6th are going to stay where they are because they're positive exponents. So when we move, I'm going to go ahead and rewrite it. I'm going to write my 2. Now this is to the 2nd power. My a to the 4th is going to move up. And then I still have my c to the 6th. And on the bottom, my a to the 2nd moves down. My b to the 4th moves down. And my b to the 8th is still hanging out there. So now we can simplify a little more. 2 to the 2nd power is 4. My a's, I have the same base, and I'm dividing, so I'm going to subtract. 4 minus 2 is going to give me a to the 2nd. I have b on the bottom, b times b, so I rewrite my b, and I'm going to add my exponents. 4 plus 8 is 12. And then I have my c to the 6th power. So that is my simplified answer. All right. Moving along. If this section, guys, is factor your expression completely. That means the first thing we look for is GCF. First, every single time. Then you look if it's 2 terms, is it the difference of squares or some difference of cubes? 3 terms, we're going to factor a trinomial. 4 terms, we're going to go ahead and do grouping. So just make sure we're following our list and we're taking out the GCF first. So in 51, I notice this is 2 terms. What do they have in common? Well, I can take out a 2, an x, and a y from both of these. So I'm going to take out 2xy. That 2xy stays out in front here. So 2 divided by 2 is 1. X squared divided by x is just going to leave me with x. And y divided by y is 1. Minus 6 divided by 2 is 3. My x's are going to cancel. And this is going to become a y. And then that's it. That's your factored expression. So now look at 3. GCF? No. So a times c. 1 times negative 14. What are the factors of negative 14 that multiply to give me negative 14 and add to give me a 5? So I'm going to say x in the front of each parenthesis. I know that's 7 and negative 2. 7 times negative 2 is negative 14. 7 minus 2 is 5. So there is my fully factored expression. All right, moving along to 55. Again, look for GCF. There is not one. So I'm going to go ahead and say a times c. 3 times negative 1 is negative 3. What are the factors of -3? They're going to multiply to give me -3 and add to give me a -2. Well, that's going to be -3 and a +1. Now, again, there's two ways to do this. Let's do it with the grouping method first. So I rewrite my first term, 3x squared. Then I have minus 3x plus 1x minus 1. And we're going to group the first two and the second two. So what can I take out of this first one? I can take out a 3x, and I'm left with x minus 1. What can I factor out of the second parenthesis? A +1, and I'm left with x minus 1. So here's my new GCF. I'm going to write it one time out in front. Whoops. Should be. And then my leftovers get their own parentheses, so 3x plus 1. Again, if you want to do it my way, we would do it the same exact way. I have my x's in the front here, and I'm going to say it's a -3 and a +1. And I'm going to take my a term and divide each factor by that a term. So 3 divided by 3 leaves me with 1. 1 doesn't divide pretty by 3, so that becomes my coefficient, and I have 3x plus 1. Same thing. All right, moving along. Same, very similar problem. A times c. There's no GCF, so I'm going to say 6 times -12 is -72. What are the factors of -72 that multiply to give me -72 and add to give me 1? It's going to be a +9 and a -8. So let's go through here, and I say, okay, in the front of each parenthesis, I have an x, a +9, a -8. I'm going to take my a term and divide both of these by 6. If you notice, neither of these simplify completely, but we can simplify these fractions a bit to make our fractions a little smaller. So 3 goes into both 9 and 6. So 9 divided by 3 is going to leave me with x plus 3/2. Here, I can divide top and bottom by 2. So that leaves me with x minus 4/3. Then my denominators become coefficients. So it's 2x plus 3 and 3x minus 4. Now, in all of these cases, guys, when you factor, you can absolutely go back and check your work to make sure that you have your signs correct and that you have your factors correct, because you should be able to multiply it back out and get your same answer as what we started with here. Same problem, I should say. All right, moving on to 57. Again, it's our GCF. No. So I'm going to go ahead and multiply a times c. So 4 and -12 gives me -48. So factors of -48 that multiply to give me -48 add to give me -13. It's going to be -16 and a +3. So again, I'm going to use x's just because my t's are going to start to look like different letters. So x in the front of each parenthesis. I have a -16 and a +3, and I'm going to divide each factor by my a term. So x minus 4, and this becomes 4x plus 3. And if you want to do the grouping method, I'll do it over here for you so you can see. So we have 4x squared minus 16x plus 3x minus 12. And then we're going to group the first two and the second two. So I can take out a 4x, my first parenthesis, I'm left with x minus 4. I can take out a +3, and I'm left with x minus 4. So my new GCF here is x minus 4. And then my leftovers get their own parenthesis, which is 4x plus 3. Again, same answer. Same answer. All right, 16. Well, first of all, I don't like the way it looks. I like to write things in standard form. And again, I'm going to change the t to an x. So I'm going to rewrite this as -4x squared plus 16. Okay, so now I'm going to say, what is my GCF? Well, I notice that I can take out a -4 from both of these factors. So I'm going to take out that -4 out in front, and I'm left with x squared minus 4. Two terms, so that's going to leave me with difference of perfect squares, x plus 2, x minus 2. And don't forget that -4. You factored it out. It needs to stay with the problem. All right. Again, I look at 61. There's no GCF, but this is something special. All right, some of you are going to say this is difference of squares. Some are going to say it's difference of cubes. What we need to see first is that this is a difference of squares problem. What times what gives you x to the 6? Well, it'd be x cubed and x cubed. What times what is going to give you -1? Be 1 and 1. So I have x cubed minus 1, and I have x cubed plus 1. Now, guys, we have discovered that there was actually 2 cube patterns inside of this original problem. This first parenthesis, my a is x, my b is 1, and this would work out to be x minus 1 times x squared plus x plus 1. My second parenthesis, my a is x and my b is 1. This would factor out to be x plus 1, x squared minus x plus 1. That's a tricky problem. That's a tricky problem. We can go over it a little more in class on Monday when you guys come in. All right, scooting along. Again, fully factor. That means we need to take out a GCF first. So I see that both of these terms have 1a in them, and both of them have at least b squared. So I'm going to go ahead and take that out. So I have ab squared, and then we're left with a cubed plus b cubed. And now we see, guys, we have the sum of cubes. So my a term is going to be a. My b term is going to be b. So I have my ab squared out in front, and it's a plus. So it's a plus b times a plus ab, plus b squared. So the last few days, I think those cube patterns are finally starting to sink in really good. So it sounds good. Oh, I didn't realize I skipped 60. I'm sorry. Let's go back up to 60. First thing I'm going to look for is so GCF. I'm going to take out 2y squared. So I have 2y squared, and then I'm left with y to the 4th minus 16. I notice here this is perfect squares, so 2y squared, and then I'm going to have y squared minus 4, y squared plus 4. And then I notice here I have difference of perfect squares again. So we have 2y to the 2nd. This is going to give me y plus 2, y minus 2, and then your y squared plus 4 stays. You cannot break that one down anymore, guys. If it's a plus sign in the middle of 2 squares and there's only 2 terms, you absolutely cannot break that down anymore. So now we'll go to 63. No GCF. I do notice that these are cubes. X cubed is a perfect cube, and so is 27. So my A term is X, my B term is 3. My pattern is going to be X minus 3 in the first parenthesis, then X squared plus 3X plus 9. 64, again, first thing we look for, say it a million times, is the GCF. So I'm going to take out a 3 in both cases here. So I take out my 3 and I'm left with y cubed minus 81 divided by 3 is 27 x cubed. And I notice again, we have difference of cubes. So I have 3, my a term here is y, my b term is going to be 3x. So I have y minus 3x, then we'll have y squared plus 3xy plus, when I square 3x, remember this 2 goes here and here, so this becomes 9x squared. All right, now we're moving along to 65. What do you guys notice about 65? How's this one different? Well, there happens to be 4 terms. So again, we're going to look for a GCF. Is there a letter and or a number that you can take out of all 4 terms? And the answer is no, but I can group these first 2 and I can group the second 2. So what can I take out of 4x cubed minus 8x squared? I could take out a 4x squared, and then I'm left with x minus 2. What can I take out of 3 and a negative 6? I can take out a positive 3, and I'm left with x minus 2. So if you guys notice here, our new GCF that presented itself is my x minus 2. And then my leftovers get their own parentheses. So 4x squared plus 3. All right, scooting now. Got one more. I notice again there's 4 terms. So can I take a single number or letter out of all 4 at one time? No, I can't. So we're going to group the first 2 and the second 2. So what can I take out of 3x cubed and negative 2x squared? Well, I can take out an x squared, and I'm left with 3x minus 2. What can I take out of 18 and 12? I can take out a 6, so plus 6, and I'll be left with 3x minus 2. So here you see the GCF is actually 3x minus 2. We write that one time out in front, and then my leftovers get their own parentheses. So x squared plus 6. All right, moving along to the next page. A lot of you were asking me questions about these first couple on this page, and it was comical because you're making it harder than you need to. Operations with algebraic expressions. What that means is you're going to be adding, subtracting, multiplying, and dividing. So if I look at 69, these 2 parentheses are written right next to each other. Nothing is in the middle. You're not adding these or subtracting these. You're just multiplying. You're foiling. So 2y times 2y is 4y squared. 2y times 7 is plus 14y. Negative 7 and 2y is minus 14y. And negative 7 and positive 7 is minus 49. Then you notice in the middle, these 2 will cancel out. So you're just left with 4y squared minus 49. Same thing here, 72. All this is a division problem. Look in your numerator. Can you factor it or anything like that? Well, let's take out an x. So I'm then left with x squared, excuse me, plus 2x plus 3 over x. I have an x out here and an x out here that we can absolutely now divide. And then can I factor this? Are there factors of 3 that multiply to give me 3 but add to give me 2? Well, the only factors of 3 that we have are 1 and 3. And if it's positive, you'd have to add them together. So no, there's nothing else to do. So you're just left with x squared plus 2x plus 3. Always check to see if things can factor, because if they can factor, we need to factor them. All right, next one. We're going to talk about this, guys. When we have radicals, we got to be careful. Remember, there's a 1 in front of here. So when we're foiling, again, we're foiling because their parentheses are right next to each other. You're going to distribute. So first times first. 1 times 2 is 2. And then x, square root of x times the square root of x is the square root of x squared. Well, what happens when you square a square root? They cancel out. This just becomes 2x. So I have the square root of x times negative 1. It's negative square root of x. So then you have, so now 1 times 2 square root of x is plus 2 square root of x. And 1 times negative 1 is negative 1. So let's talk about what we can combine here. All right, 2x is not going to combine with anything, but I have negative 1 square root of x plus 2 square root of x is going to give me plus 1 square root of x. You don't have to have the 1, but I'm just showing you so you can see it, minus 1. And that's all you can combine, guys. You cannot combine the 2x and the square root of x because those are not like terms. They're not exactly the same, so you cannot combine them. Make sure you are paying attention to that. All right, where else do I lost everything. Okay, so I go to 76. Now we're dividing, but I can factor. You guys have got to factor first. When you're adding, subtracting, multiplying, and dividing rationals, when we are talking about fractions, we have to factor first. So I notice in my numerator here, I have the difference of cubes. So my a term, again, I'm going to change my t's to x's, is x. My b term is 1. So my numerator is going to become x minus 1 times x squared plus x plus 1. My denominator, I notice, is the difference of perfect squares. It's going to be x minus 1 and x plus 1. So do I have anything in my numerator and denominator that are exactly the same? Yes, this x minus 1 can cancel with this x minus 1. And then this is my final answer. There's nothing else to cancel out. You can't just cross off x's or cross off the 1s because they are attached with plus and minus signs. Make sure you guys are aware of that. All right, so now at 77, I have 4 factoring problems. We are multiplying rationals, so all we're going to do is factor each piece. So top left, numerator, factors of -3 that multiply to give me -3 and add to give me a 2. It's going to be x plus 3 and x minus 1. So that's gone. Now I'll change colors. Let's go to the bottom left. What are the factors of 16 that multiply to give me 16 and add to give me 8? It's going to be x plus 4 and x plus 4. That one's gone. Over here on the bottom right, I have nothing to factor. I just have x minus 1. So I'm going to go ahead and put it in parentheses so I see that it's together. And then in my top right, I'm going to factor out a 3. So I'm left with x plus 4. Now, anything in the numerator and denominator that is exactly the same, we can cancel out. So I have an x plus 4 here and an x plus 4 here. We can cancel out. I have an x minus 1 and an x minus 1. And I think that's it. That's all we have for factoring out. So what are we left with? Well, don't forget about this lone 3 here. So I have 3 times x plus 3 over x plus 4. And just leave it like that, guys. There's no reason to multiply it back together. Leave everything in its factored form, and it'll make your life easier. All right, so now I look at 78. How is 78 a little different? Well, we are, instead of multiplying, we're dividing. So the first thing you guys need to remember to do is keep, change, flip. So I'm going to go ahead and just rewrite everything. I have x squared minus 2x minus 15 divided by x squared minus 6x plus 5. I'm changing my division sign to multiplication, and then I flip. This becomes x squared minus 1 over x squared minus x minus 12. And now we're going to go and just do exactly what we just did. I'm going to go to the top left. I'm going to factor. What are the factors of -15 that multiply to give me -15 and add to give me a -2? It's going to be x minus 5 and x plus 3. So that's done. Bottom left, what are the factors of +5 that are going to multiply to give me +5 but add to give me a -6? That's going to be x. So that's going to give me a -5 and a -1. So when I add those two together, I get -6, and I multiply, I get +5. And then I'm going to go to the bottom right over here. What are the factors of -12 that multiply to give me -12 and add to give me a -4? Sorry, -1. That's going to be -4 and +3. And then in my top right, you guys will notice I have the difference of perfect squares. So x plus 1 and x minus 1. So now we factor. We have already factored. We've factored fully all numerators and denominators, and now we cross out what is exactly the same on the top and the bottom. So I have an x minus 5 here and an x minus 5 here. I have an x plus 3 and an x plus 3. I have an x minus 1 and an x minus 1. So what are we left with? We're just left with x plus 1 in your numerator and x minus 4 in the denominator. And that's it. It's a fun little problem. I love this. All right, 3 more to go. Number 82, I am adding and subtracting rationals. So again, the first thing we do is we're going to fully factor. Fully factor, fully factor. So the first thing I look at is I say x plus 2. That's done. My second fraction is going to be x minus 2, x plus 2. And then my third fraction is going to be x minus 2 and x plus 1. So we've got to get a common denominator between all three of these before we can combine like terms and all that stuff. So my common denominator is going to be a combination of what each of them has and what each of them are missing. So everybody needs an x plus 2. My pen's dying. X plus 2. I have an x minus 2. And I have an x plus 1. So we look at each fraction independently. This fraction has the x plus 2. What's it missing? It's missing x minus 2 and it's missing x plus 1. So what you do to the bottom, x minus 2 and x plus 1, you have to do to the top. My second fraction has the x minus 2, x plus 2. It's missing the x plus 1. So I'm going to multiply the top by x plus 1. My third fraction has the x minus 2x plus 1, it's missing the x plus 2. So what you do to the bottom, guys, you do to the top. So I'm going to rewrite everything so you guys can see it. In my first numerator, I have x minus 2 times x plus 1 plus my second fraction, I have the x plus 1. And then my third one, I have minus 2 times x plus 2. Before you guys can do anything trying to cancel out, you have to combine like terms in the numerator. I have a plus sign here, and I have a minus sign here. All of these things are connected, so you can't just start crossing out. So we've got to go ahead and FOIL. I'm going to FOIL the top here. X times x is x squared. X times 1 is x. Negative 2 times x is minus 2x. Negative 2 and 1 is minus 2. Then I have plus x plus 1. And then we're going to distribute. So minus 2x minus 4. And that's all over x plus 2, x minus 2, and x plus 1. So now we combine like terms. What do we have in common? Well, I have an x squared. Nothing else has an x squared, so I'm just going to write my x squared. So I have x's. I have 1x minus 2x, that's negative x, plus x, 0, then minus 2x. And then I have a negative 2, a positive 1, so negative 1 minus 4 is going to give me negative 5. And that is all going to go over my denominator of x plus 2, x minus 2, and x plus 1. And then lastly, now you can say, all right, can I factor my numerator so I can cancel things out? Are there factors of negative 5 that'll multiply to give me negative 5 and add to give me negative 2? No. So we're done. That is a fairly long problem that you guys need to be able to do. So make sure you guys follow along. Let's do some extra practice on Monday in class. All right, 84. Just 2 of those problems we just did in a division. So I'm going to label this blue. We're going to work on the numerator, and then we'll make our denominator red. And then we'll worry about the keep, change, flip. So in my top fraction, my common denominator between x and x plus 1 is just going to be x times x plus 1. So my first fraction has the x. What's it missing? The x plus 1. My second fraction has the x plus 1. What's it missing is the x. So in my blue fraction in the top, I have x plus 1 minus 1x. So when we simplify this, it just becomes 1 over x times x plus 1. So now I'm going to look at my denominator. I'm going to do the exact same thing. So I'm going to say, okay, what's my common denominator between these two? Again, it's going to be x times x plus 1. So my first fraction has the x. It's missing the x plus 1. My second fraction has the x plus 1. It's missing the x. So in my denominator fraction, rational problem, however you want to look at it, I have x plus 1 plus x. So when we combine like terms, that gives me 2x plus 1 over x times x plus 1. So what I have done now is simplified my numerator of my fraction, then I've simplified the denominator of my fraction. And now I can keep, change, flip. So keep, change, flip. This becomes 1 over x times x plus 1. I'm going to change my division to multiplication, and then I'm going to flip. So this becomes x times x plus 1 over 2x plus 1. And now anything on the top and bottom that is exactly the same, I can cross off. So my x and my x here, the x plus 1 and the x plus 1. So what am I left with in the numerator, guys? Just a 1. And what am I left with in my denominator? 2x plus 1. And there is your complex fraction, simplified. All right, lastly, let's look at number 90. What's the problem here? I have a radical in the denominator. I cannot just multiply the top and the bottom by the square root of 2 because the square root of 2 is negative and it's stuck together with the 3. So we're going to multiply by the conjugate. What is the conjugate or the opposite of 3 minus root 2? It's 3 plus the square root of 2. And what you do to the bottom, guys, you do where? To the top. So let's work on our denominator first. Make sure our radical cancels out, which is what we need to happen. 3 times 3 is 9. 3 times positive root 2 is plus 3 square root of 2. Negative root 2 and 3 gives me minus 3 square root of 2. And negative root 2 times positive root 2 gives me minus the square root of 4. So let's simplify. 3 root 2 minus 3 root 2 cancels out. The square root of 4 is 2. Good. So that in your denominator, 9 minus 2 gives you 7. So the whole point of this is to get rid of the radical in the denominator, which we have done. So now let's go ahead and distribute in the numerator. 14 times 3 is 42, plus 14 times root 2 is 14 square root of 2. So this becomes 42 plus 14 square root of 2. When you guys simplify, you've got to make sure that when you simplify, you do this completely. What can I factor out in my numerator, right? What goes into both 42 and 14? Well, 7 does. So when I factor out a 7, 42 divided by 7 is 6, plus 14 divided by 7 is 2, square root of 2, all over the whole number 7. So now that I have done that, I see, oh, wait a second, this 7 cancels with this 7, so I'm left with 6 plus 2 square root of 2. Some of you might say, well, can't you simplify further? I mean, you can. Technically, you could take, what do they both have in common? They both have a 2. So I can take out 2. 6 divided by 2 is 3. Plus 2 divided by 2 is 1, so square root of 2. Both of these things are exactly the same. Both of these are exactly the same, and they are equivalent to this. But make sure if you're going to simplify, you've got to simplify everything in the numerator with the denominator. So guys, come to class please on Monday, asking questions. Bring your old quizzes, bring your old tests, anything that will help you. There's a few extra problems that are in the end of the worked out solutions that I'm going to go over with you guys on Monday. I just wanted to make sure that I touched upon everything in these last few chapters and such. But we're going to go over stuff, and we're going to talk about how to simplify. Like, what's the difference of 2 to the 6th power, or negative 2 to the 6th power, or 2 to the negative 6th power. Now, all those things look very similar, but we've got to be careful of where negatives are. Like if this negative were out here, this means to perform 2 to the 6th power, which is 64, and then stick a negative in front of it. The second problem says take negative 2 and multiply it by itself 6 times, which would be positive 64. So make note of where the parentheses are. This problem says I want to raise 2 to the negative 6th power, so I have to put it in a denominator first. It'd be 1 over 2 to the 6th, which would then be 1 over 64. Those sorts of things are what we really, really, really need to focus on and pay attention to and make sure that we understand. You could have a problem like this, operations with radicals, where it's the square root of 20 minus the square root of 125. Well, you can't do anything with these right now the way that they're written. You have to break them down because you can only add and subtract if they have like radicals. So I'm going to rewrite 20 as 4 times 5. And I'm going to rewrite 125 as 25 times 5. And now I notice, oh, wait a second. Now I can simplify this because the square root of 4 is 2. That comes out. 5 stays inside. Second one, I can say, oh, the square root of 25 is 5. So that comes out. I have 5 root 5. And then I notice, oh, now my radicals are the same, so I can subtract. 2 minus 5 gives me negative 3 square roots of 5. What else? What about if we had something like 3 times x plus 6 plus 4 times 2x minus 5? Well, guys, what are we doing here? First thing we're going to do is distribute. 3 times x is 3x. 3 times 6 is 18. Plus 4 times 2 is 8x. 4 times negative 5 is negative 20. And we can combine like terms. 3x and 8x gives me 11x. 18 minus 20 is a minus 2. And that's it. You're just combining like terms. What's another thing we can look at? What about if we had 2x plus 3 raised to the 2nd power? Well, what does that mean? That means I have how many 2x plus 3's? I have 2 of them. So I'm going to rewrite 2x plus 3 times 2x plus 3, and we're going to FOIL. The middle terms will not cancel out here, guys, because you have all positive. So 2x times 2x is 4x squared. 2x times 3 is plus 6x. 3 and 2x is plus 6x. And 3 times 3 is 9. So this becomes 4x squared plus 12x plus 9. And that is how our perfect square trinomials are formed. So we will go over some extra problems in class. I promise we'll practice a little more, and you guys will be ready for your test on Tuesday. Have a great weekend.